Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Find your dream aviation and aerospace jobs at www.wingsofarrow.in/jobs. Now we are going to learn about how to find the acoustic velocity of air measured by Pitot tube in wind tunnel. Consider a Pitot tube in a wind tunnel. It gives a static pressure reading of 40.7 kg force per centimeter square and a stagnation pressure reading of 98 kg force per centimeter square. The stagnation temperature is 90 degrees Celsius. Calculate the acoustic velocity. Given data. Here the static pressure of air which is measured by the Pitot tube P1 is equal to 40.7 kg force per centimeter square and stagnation pressure P suffix T is equal to 98 kg force per centimeter square. Stagnation temperature T suffix T is equal to 90 degree Celsius or 363 Kelvin. Now the question is, what is the acoustic velocity? A Pitot tube is a flow measurement device used to measure fluid flow velocity. By definition, the change in density of an incompressible fluid is zero. This means an infinite velocity of sound. However, the real fluid are not truly constant density fluids and always have a finite acoustic velocity. For a perfect gas, the velocity of sound or acoustic velocity is given by A is equal to square root of G naught into gamma into RT, where G naught is the acceleration due to gravity, which is 9.81 meter per second square. R is the universal gas constant, which is 29.27 kg force meter per kilogram Kelvin for air. Gamma is the ratio of specific heats, which is a function of temperature only. It can be concluded that the velocity of sound or the velocity of propagation of a small disturbance, which depends only on the nature of the gas. As we know, gamma is 1.4 and T is the static temperature. This is unknown. So first find static temperature and then we can find the required velocity. So from isentropic relation we can write T suffix T divided by T is equal to P suffix T divided by P to the power gamma minus 1 divided by gamma. From this we can solve for static temperature. Then T is equal to 282 Kelvin. Now we can find out the velocity. Substitute the values in equation number 1 and solve. We get the required acoustic velocity is 338 meter per second. Did you know the new space race? In 2010, SpaceX became the first company to launch a privately built spacecraft into orbit and return it safely to Earth. The company is now aiming to become the first to dock a commercial space capsule to the International Space Station. Still, Musk has even loftier goals: to be the first entrepreneur to put an astronaut in orbit. The company intends to use a version of the robotic Dragon capsule to one day carry astronauts to the orbiting outpost and other destinations in low Earth orbit. Musk has also been outspoken about the need for humans to become a multi-planet species to survive. Eventually, he plans to modify the Dragon spacecraft to one day land on the surface of Mars. Killing a Tsar. In 1881, the history of rocket propulsion took an odd turn when Nikolai Ivanovich Kibalchich, one of Russia's rocket pioneers, took part in the assassination of Tsar Alexander II. As the main explosive expert, Kibalchich shot 4 projectiles at the Tsar and killed him. The 27-year-old genius would be arrested and executed, but was still hard at work on mathematical equations while he sat in prison. Nazis at it again. Germany was actually the first country to produce a rocket capable of crossing the boundary of space. The famed V-2 rocket of World War II was a ballistic missile launched by the Nazis on England and Belgium.
If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired, and fly high.